Okay, I think things are slowing down, so I'll just go ahead and get started. I'm Charlie Nunn. I'm at Duke University in evolutionary anthropology and Duke Global Health Institute. And I also run the Triangle Center for Evolutionary Medicine. And this is Club EvMed. I see a lot of familiar faces out there. You guys know what this is about. This is our opportunity to bring together the community and talk about the latest research and to have a discussion about that research, right? So we try to call it evolutionary medicine conversations so that we can actually have a conversation about the work that's going on. And of course, we like to really focus on cutting edge new findings, especially things that really push the frontiers of the field. And we have a good example of that today. I want to point out, as I always do, that Club of Med is organized by a number of different evolutionary medicine centers. I just posted those in the chat. And also the International Society for Evolution Medicine and Public Health, and I'll put that in the chat too. It's just a little bit too much text to put it all in one paste. But as everyone, I hope, knows, the International Society for Evolution Medicine and Public Health is really the society for evolutionary medicine. We have a great journal, Evolution Medicine and Public Health. I hope you're familiar with that too. And finally, I hope you're familiar with our annual conference, which is going to take place in Kiel, in Germany, July 28th to 31st. And so we really hope to see a lot of you at that conference this summer. Okay, I still see people coming in. We had a lot of people register for this one. I guess we're just going to keep rolling people in as they come. It's a real pleasure today to introduce two people who are going to give a presentation. Chris Kozawa, professor of human evolutionary biology at Harvard. He's very well known to those of us in evolutionary medicine, especially the biological anthropologist amongst us. He got his PhD in anthropology at Emory, also a master's of public health in epidemiology from Emory University. He was at Northwestern for many years, and he's a member of the National Academy of Sciences and the American Academy of Arts and Sciences. And with Chris today is a PhD student in his research group, Sasha Post. He's a second year PhD student in human evolutionary biology at Harvard. He studies pregnancy as a period when ecological information is transferred between generations. He got his undergraduate degree from University of South Florida. That's where he's from originally. And he is going to talk to us about his work. He also speaks Dutch, I noticed, which is probably relevant for some of what we're going to hear today. So I'll turn things over to you, Chris, and then I think you guys are going to go back and forth if I understand correctly.
Yeah. Okay. Let's see if this works. Hold on a second here. There we go. Well, thank you so much for this invitation to present at Club EvMed. This is awesome. This is work in progress. So this is the first time we're presenting these findings, but we're starting to write them up. So we're pretty much done with the literature review, and it's a really good moment for us to get some feedback and see how, see if it's clear how we're presenting this. But so what we're going to do is I'm going to set the stage. I'll do some background into DOHAD and so on, and that's sort of what motivated like this analysis. And then I'll hand it off to Sasha because Sasha really spearheaded the systematic review of the literature, and he'll tell everybody what we did and what we found. And then finally we'll come back to me and I'll provide a little bit of wrap up and context. Okay, so I'm going to begin with this here. This just shows that cardiovascular disease is rising globally, and it's now the leading cause of death basically everywhere, like lower income, higher income countries. It's the main cause of death. And that has accompanied parallel changes in lifestyle, right? Diet and physical activity leading to increased weight gain and obesity and so on, right? And so we really associate cardiovascular diseases with overweight. We even call them diseases of excess. And by the way, that includes heart attack, stroke, diabetes, hypertension, kidney disease, right? So it's all these metabolic diseases. So that link with overnutrition is classic, right? We've known that for a long time. And then comes along David Barker in the late 80s and early 90s, showing these very different relationships where lower birth weight is associated with higher rates of heart disease, right? This inverse linear relationship. And what he proposed, of course, when a fetus is undernourished, it's going to slow its growth rate and you get lower birth weight. But his insight was to suggest that the fetus is also adjusting all these other biological systems in ways that are durable, right? And that go on to influence risk for cardiovascular disease. And we have really good experimental validation of this idea in animal models. So this is in guinea pigs. You see there's fasting glucose here in all these groups, and then they have the glucose infusion pops up, and then their bodies start producing insulin, and they removes the glucose, and they come back down to fasting status. The open circled individuals here, their mothers had their diet restricted by 30%, and you can see they're clearing their glucose just fine. But when you look at their insulin levels, okay, they're overproducing insulin in the fasting state. They overproduce insulin in response to the glucose, right? So they're having to work harder at it, which shows that their tissues are resistant to the effects of insulin, which is how you eventually become diabetic. So this kind of experimental work really validates the concept that fetal nutrition probably underlies some of these associations that we see in humans. And so big implications of this, right? So there has been a big policy focus, and probably many of the people on this call have heard of this concept of the first 1,000 days. You see this everywhere, right? This has really taken off in the last 5 or so years. And the basic idea is that from conception to pregnancy, and then the 2 years after that, the first 1,000 days of the life cycle are kind of a critical period when nutrition interventions can have, be expected to have long-term benefits, particularly in that window. And we'll come back to that. And then the other piece of this, so there's like the policy piece, and then there's sort of the evolutionary medicine, evolutionary biology piece, which has to do with speculations around whether or not there might be information in that signal. Is the fetus getting information about the environment that it'll be born into, allowing it to kind of adjust its metabolism and its biology in anticipation of that adaptively? And so Pat Bateson wrote about the mother sending a weather forecast, and Gluckman and Hansen, everybody's probably heard of this concept of predictive adaptive response, right? So these are examples of that. Those ideas have been critiqued by virtue of the fact that, does it really make sense to set your biology for life based upon happens to be going on in, a few months during gestation, right? You're going to live 70 years, and maybe you're born during a famine or during a bad time, right? Do you set your biology permanently based upon that? So that's one of the critiques that's been leveled at that. But what both of these frameworks, whether it's policy or the adaptationist ideas, what they share in common is the assumption is that what the mother eats during pregnancy is getting through to the fetus, that the fetus is actually receiving that nutrient, right? And that's impacting its biology. Now, I already showed you good experimental evidence from guinea pigs. We also have it from rats and sheep and other species. But the problem is that most human work on this has been observational. It's correlational, right? So here is a meta-analysis. This is just replicating what Barker showed, right? As birth weight goes down, risk for diabetes goes up. This happens to be in almost 8 million people. So it's, pulling lots of studies. So this has been replicated many times. The problem, of course, is that this is not evidence for a causal role of nutrition. Yes, nutrition is part of the story, but it's also a function of genetics, birth weight, that is, whether or not the mother smoked. It tells you something about the socioeconomic environment that individual will be born into and raised in, right? So their diet, etc. So it's highly confounded. And because of that, of course, we want to see experimental evidence in humans, right? And so on the one hand, supplementing the diets of women is unproblematic, and that's been done a lot, even preceding Dohad and the Barker hypothesis. There have been many attempts at this, right? Because birth weight is a strong predictor of infant mortality. So what do we see here? Does pregnancy nutritional supplementation increase offspring birth weight? And not really. Okay, so this is in adequately nourished women. This is a meta-analysis, Cochrane database systematic review. And you see that in these adequately nourished women, there's an average of about 1 ounce of extra birth weight, not significant. When you look at the 9 studies that were of undernourished women, it's a larger effect size and it's closer to significant. Now, if you drill into this and actually look at each study, you'll see that the reason that these two coefficients are different is because of one study that happens to be over here. And it's the study in the Gambia. And it's a very famous study, Cannibal, right, where they've done multiple nutritional supplementations. And what they find, okay, so the Cannibal is unusual because the nutritional stress is chronic there, and there's really severe seasonal food shortage. So what they find is that women who are pregnant during the wet season, right, during the hunger season, which also happens to be the wet season, so there's a lot of infectious disease, they don't have enough food, and they're working in the fields, they actually lose weight while pregnant. And so you supplement during those few months and you get a big boost in birth weight, but across most of the year you don't see much, right? So overall, the sort of findings of these nutritional supplementations have have been not great. They have in Gambia, they also tested some of these DOHAD ideas, right? So they followed up with some of the offspring who were in utero when the supplementations happened, when they were in adolescence, and they find no evidence, right? So this was a study where they looked at glucose and blood pressure and other things. Here's a study where they looked at blood pressure, does not have any association. Here's one where they looked at body composition, some found no effects of being in utero during the supplementation. And then they also looked at cognitive outcomes. Nothing. And I want to emphasize that these are not like nudging in the right direction. Most of these are completely flat. There's really no evidence here for an association. So that's, unfortunately, the evidence that you can improve health using nutritional supplementation during pregnancy, having an intergenerational effect on the fetus, is pretty paltry. Right? Minimal support there. Of course, we cannot randomize people to stress, but history has done that for us. All of these are political events. They're all wars and conflict and so on, right? With the Dutch famine, the Great Leap Forward, the Biafra famine, and Ukraine. The latter three of these are a little less controlled. They're more ecological. Most of the focus here in this literature has been on the Dutch hunger winter and Dutch famine studies, and that's what we're going to focus on. And my relationship with these findings goes back quite a while because I wrote my first dissertation improvement grant, NSF grant, in 1997 to test what was then the Barker hypothesis. It was like 30 years ago in the Philippines study, the Cebu Longitudinal Health and Nutrition Survey, which I'll talk about a little bit later. And I focused on cholesterol. So I spent a year and a half there, came back, was writing up my dissertation in 2000, and then, oh, and by the way, yes, we know that there's a lot of press around this study, right? Like emphasizing that prenatal famine elevates risk for later disease. So that's, I think everybody on this call is aware of that, and that's sort of the background. But when I was writing up my dissertation in 2000, this paper came out, and the conclusion was an atherogenic lipid profile might be linked to a transition from poor maternal nutrition in early gestation to adequate nutrition later on. This suggests that maternal malnutrition during early gestation may program lipid metabolism. Very excited to have this paper to cite as I was writing up my own work. But when you look at it, there wasn't actually a whole lot there. What there was one significant relationship. Early exposure was associated with an elevated LDL to HDL ratio. But I still cited it, of course. One thing I want to point out, this particular study did Bonferroni correct, right? So there's obviously a lot of different tests being done here. And ideally, you would adjust for multiple comparisons. Almost all of the Dutch famine work does not. And so most of what we will be talking about is not Bonferroni corrected. This study happens to be. But then about 10 years later, and I want to point out, this is the Amsterdam group. We're going to learn more about this from Sasha. There's multiple cohorts. This is the Amsterdam group, okay, their study of this. A kind of a replication based out of Colombia, a different cohort, different study design. 10 years later, they look at the same outcomes. And lo and behold, there are some elevations in cholesterol related risk among women exposed in utero to the famine, but when you look at the men, it's actually the opposite. They look to be protected. Okay, so it starts to look kind of murky here. And then, I was doing paper, when I would give talks and so on, I wanted to have a quick table where I could sort of start to compile some of these findings. And this was very crude. I was looking for the key findings from the different studies. And this is what I was finding, not a whole lot there. One of the things that is not necessarily a classic DOHAD outcome, but is actually one of the original outcomes that motivated some of the early Dutch famine studies were cognitive outcomes. And I want to focus on one of these here. This is from 1972, one of the earlier Dutch famine assessments. The authors conclude the findings point either to a high order of protection afforded the fetus in utero or to great resilience of the fetus or to nutritional insult or to both, right? So there was no effect here. And there was this fascinating interview, and I need to get rid of this. Sorry, there we go. Interview with the lead author of that, who was really the architect of some of the early Dutch famine studies, Zena Stein. Interviewer, our data don't always support what we might believe is the best for public health. Has this ever happened to you? Zena Stein, yes, with the Dutch famine study especially. We found no evidence that 6 months of starvation and pregnancy among a reasonably well-nourished population had any effect on the intelligence of offspring. Many of our colleagues were furious because it would have been much more satisfactory in terms of social justice to have found that food did matter. But in fact, nothing has happened since to change that opinion. What we have learned is that certain nutrients, particularly folates, can make a difference depending on timing and outcome, but not general starvation in any direct way. right? So it became clear, instead of having this back of the napkin kind of quick and dirty table that I had, that it was time to actually dig into this literature and look at all the studies, right? There's multiple cohorts, multiple designs, multiple outcomes. Look at it all systematically, and that's what we've been doing. So for the last year, this we've been doing this. Sasha, who you're going to hear from in a second, really led the analysis, working with Ellie Klibner-Schiff, who's a graduating senior. She would be on this call, but she's actually in class right now. And then Zane Thayer is going to be part of our writing team moving forward. Zane is camping at Chaco Canyon, so she also can't be on the call, and I'm jealous. So that's the background. And now what I would like to do is hand it off to Sasha, who's going to tell you what we actually did and found.
Let's see. Uh, can you guys see this? Great, great,
Yes, it's
great.
good.
Cool. Well, thank you, Chris, for the wonderful setup, and thank you everyone for being here. I'm really excited to be presenting today. Um, I'm going to give like a little bit of background on the Dutch famine and its origin, and then we'll get more into the methods. But I'm going to do this dramatically too. I'm very excited. Okay, it's September 1944. The Allies have successfully landed in Europe. This is Operation Overlord, D-Day on June 6th. This photo was taken on June 9th. And Operation Overlord extends to the liberation of France and Belgium. And they've been incredibly successful. You can see this is a map of the front of the war over August to September. And by September 14th, the war front has moved all the way out of France to the border of Belgium, basically pushing up against Germany. And it's right underneath Holland, which I've circled here. And so a new operation was underway. It was called Operation Market Basket. The hope being that Allies would be able to keep up their momentum and take some key bridges and get into Holland to push out the occupying Germans. Um, so, feeling this momentum, the Dutch government, in absentia from London, used their pirate radio, Radio Orange, brought to you by the BBC, to call out to Dutch railway workers and ask them to go into hiding, to basically go on strike. And the hope here was that that would prevent Germans from using Dutch rail infrastructure and thereby help the Allied cause. Uh, Germans obviously weren't very happy with that idea and made a threat. This says striking will bring only misery to your own people. Um, but despite these threats and the adversity they faced, Dutch rail workers went on strike. They went into hiding. But unfortunately, it wasn't enough. And Germans were able to keep their war machine running in the Netherlands and repel the Allied advance. However, they didn't forget what the rail workers had done. And in November of 1944, they imposed a blockade on food and fuel onto Holland. And this is the region of the Netherlands where all the really big cities are. So it's like Amsterdam, Rotterdam, Den Haag, Utrecht. This is where my family is from. Both of my grandparents lived through the famine. In fact, my grandfather loves to talk about how he really likes Hershey's chocolate because that was the chocolate in American military rations dropped on the Netherlands when they were liberated. Um, but it was like a really rough time. 20,000 people died. Here's a photo of a victim. His name was Henky Holvost. Uh, he's a kid. You can see how little fat he has on his body just looking at his knees, right? And kids were encouraged to carry around a spoon just in case they happened to find food. Like it was meant to be hopeful. Just another fun fact: this photo was taken by a resistance photographer who survived the war and went on to take photos of the Queen. So gotta love it. Um, let's see. So this was a really severe period, and it was like sharply demarcated. We knew when it started and when it ended. It was over by May of 1945 when Allies did successfully drop food into the Netherlands. So you can see there's this like precipitous drop in daily caloric intake, almost as low as like 600 calories per day, depending on who you were and what food you were rationed and whether or not you had access to like black market additional food. So this, as Chris alluded to, made a really rare quasi-natural experiment with which to test the Doehead paradigm that famine in utero produces these lifelong health consequences. And so people have been testing this a lot for the last like 70 years. Um, there's two main approaches that people have been using to get at this question. One is employing administrative data sets. So these are really large, like national data sets. And the other are the longitudinal cohorts that are probably more familiar to everyone. That's like Amsterdam and Colombia. But first, so um, These administrative data sets are very, very large. They're national. They have records of everyone in the Netherlands, um, and including this can include like their date of birth and then certain health outcomes. So the most common one I think is the military induction data set. So at 19, all Dutch men had to undergo compulsory medical examinations for mandatory military service. And so depending on the study, they had 40,000 to 400,000 individuals with BMI, um, cognitive outcomes, anything that would happen during a typical military draft. Uh, then the other data set that's really common is the Dutch Psychiatric Registry. And this is a record of admissions to psychiatric care facilities along with the reason for admission. And generally speaking, studies that use this data set have about their sample size is about 150,000. And so these are really valuable if you want to get at an outcome that is very low prevalence. Like we'll talk about schizophrenia, but that's like 2 per 1,000 people. So this is well powered for those questions. The other study approaches use longitudinal cohorts. So the first one and the one that Chris was alluding to earlier is the Dutch famine birth cohort. It's based out of the University of Amsterdam. It uses hospital controls. So everyone in the study is born in Wilhelmina Gasthuis, which is a hospital in Amsterdam. It's now part of the University of Amsterdam. Exposed individuals were in gestation during the famine window, and then unexposed individuals were in gestation either well before the famine window or well after the famine window. But they were all born at the same hospital. And so the end frame, it's a cohort of about 2,500, but their samples are normally somewhere between 500 and 1,000 people, whoever they can get into the lab. The other cohort is the Dutch Hunger Winter Family Study. This is based in Columbia University. It uses both hospital and sibling controls. So um, it has individuals born in hospitals with like the pre and post control format, except it's at Rotterdam, Leiden, and Amsterdam, Rotterdam, and Leiden. And then they also have for about 300 individuals who are in utero during the famine window, sibling controls. So siblings who are unexposed to famine, typically younger siblings. And this helps get at like family effects, right? If there's something about a family that allows them to have a pregnancy during the famine window, but might also contribute to adult health outcomes, they can start to control for that effect. And because they have multiple birth clinics, their end frame is a little bit bigger, and their sample, whoever they get in the clinic, tends to be a bit bigger. It's normally like 900 to 1,000 people. Cool. So just to really drive home how heterogeneous these studies are, this is a diagram from 2007 when Lumi was first beginning his career. He's one of the Dutch famine researchers at Columbia that just shows like what this is 5 different ways that they define exposure. This is expanded since, so there's probably another like 7 or 8, or excuse me, there's probably 7 or 8 total, so another 2 or 3. So we wanted to kind of get at this question of what is prenatal famine exposure doing, but also take into account like there's a lot of different ways you can define famine exposure. Cool. So to get at this heterogeneity, we first wanted to just find papers, right? We wanted to try and cast a wide net and get as many papers as possible. So we used very general search terms in PubMed. These are all just synonyms for the Dutch famine, Dutch hunger winter, Hungerwinter, the 1944-45 famine. And then this returned 214 articles published between 1952 and 2025. We gave the abstracts from these articles to a screening software called Ryan, which removed duplicates. Typically, it's like letters to the editor or something, things that would have the same title. And then that gave us a starting sample of 210 publications. Next, we had to do an abstract screening just to make sure that the papers were actually relevant to our interests. So our inclusion criteria were about prenatal famine exposure. That was really it. And then we didn't want any reviews, right? So we wanted to find some empirical papers. Um, this is something that Ellie helped me with. We spent, I think, last spring just reading these abstracts independently. And then once we finished all 210, we would come together, check to see where we were conflicting, make sure that we had interpreted our inclusion criteria correctly, and if there was any conflict or any confusion, and we just wanted to be conservative, we would send a list to Zane and Chris, and they would make final call on which papers we included. Um, and that yielded 92 papers. So these are empirical papers that we're now working with. So next we did a full text screening. So this is what I spent my last summer on. I read all 92 papers and I coded them. I, made sure that we knew what outcomes were being measured, what controls were being used, which cohort was running it, all that. Um, and while coding it, I could check for a stricter inclusion criteria. First, that we were testing direct associations between prenatal exposure and adult outcomes instead of like interactions with the genetic variant, or there's a lot of papers from Amsterdam about like lipid profiles and their interaction with famine exposure and like brain outcomes. So we tried to keep it simple. And then we wanted to focus on cardiometabolic and cognitive health outcomes because we consider these to be like fundamental DOHAD outcomes and also original parts of the study, right? What were we actually trying to measure? As opposed to like, there's some papers about sexual orientation, its relation to famine exposure, or like occupational attainment. So those are harder to interpret, and we didn't want to get bogged down. Um, this yielded 421 associations across 38 plus one empirical studies. We realized post hoc that our inclusion criteria missed an important paper, so we folded it in. Um, and then from these papers, we recorded linear model coefficients and ratios uh, as they were grouped by exposure. So like first trimester, second trimester, or Q1, Q2, Q3, Q4. And then we also recorded modeling design for those studies and any other study characteristics which were pertinent. And let's see. So I'm gonna just show you all of our data. Don't try to digest it because it's a lot. It's a living document. There's notes in here, and I just want to give you a sense of the, I guess, the variation in these studies and also the magnitude. So this is basically what we've been working with. You can see we've got age of participants in the study all the way on the left, and then we record the phenotype and how it was measured. We have a couple different ways that we record our controls. Then we have all of our outcomes, right? The sample of the study, as well as the frame from which that sample was pulled, whether these relationships are pooled by sex or if they're stratified, a Ryan reference so that we can go and look at notes that we made when we first did our screenings, a link to the original paper, and then who did the study, so what was the cohort, and any notes on study design or what models were adjusted for. So I'm just going to flip through these. You can see like there's some trimester stuff because it's grouped in three columns. Oh, hang on a second. There we go. More trimester stuff. There's some stuff that's grouped by any exposure. Um, let's see if I can find. Here's some stuff from Colombia. They always do quarters instead of trimesters because they use like a last menstrual um, period as their indicator. Um, there's a lot of different kinds of tests. Some people use walled tests. Some people test individual associations. That's probably why not anything, like maybe one or two studies in here are actually Bonferroni corrected. So yeah, there's just a lot of heterogeneity that we wanted to deal with. Um, yeah, so I'll like rest your eyes for a moment after that rainbow. Um, but we needed to figure out how can we simplify all of this information, right? This has been decades and decades of research, and we want to talk about it in a productive way without getting, I guess, lost in it. Uh, so first, we start plotting it. We wanted to plot only well-established and interpretable outcomes, so things like blood pressure, hypertension, that kind of stuff. Um, we wanted to focus on risk factors that were measured at the earliest age possible in each data set, with the assumption being that the unhealthiest people in a cohort would die earlier. So as a cohort ages, they'll actually get healthier. Um, and so we wanted to really make sure that we were recording any effects that could increase mortality. And then lastly, we recorded mortality at the latest age possible. So this would be um, as cohorts age, we wanted our sample sizes to be as large as possible. Um, then we make our force plots. Obviously, we're plotting both linear outcomes and ratios. So to make them more directly comparable, we log transform ratios so they're centered on zero, and then we use standard error to standardize all effect sizes. So this just makes it more pretty and interpretable. Cool. Uh, yeah. Oh, also, I'm just going to drive this point home. Um, Almost none of the studies do a multiple hypothesis test correction, except for maybe the one that Chris showed you earlier in the table. That is the lipid profile. And so we actually report the uncorrected results, just to keep it comparable with all studies. So really, really emphasizing that. Um, yeah. So we found some inconsistencies across the study designs and by sex. And we're going to do this in a series of vignettes. I really like that word. Chris is using that word a lot when we made this presentation. Uh, so we're starting with cholesterol because that's his favorite. Um, and what we found is from the Amsterdam cohort, there was evidence for a negative effect after early prenatal famine exposure, but maybe a beneficial effect after mid to late exposure. And you can see this really clearly in this plot. We just have our cholesterol on like the y-axis and then these standardized coefficients on the x, and they're grouped by exposure category. So in early gestation, you see these red cells in our forest plots. That indicates significant and then a marginally significant result. So p-value less than zero point 0.1 across a couple different measures. And then there's also these beneficial effects in mid to late gestation with total and LDL cholesterol. And if you do the Bonferroni correction, it's only the ratio that remains significant. Cool. Uh, the cool thing about having two longitudinal cohorts is that they can check each other. Um, and what we see is that in Colombia, there was not such a consistent effect of early famine exposure. Um, Actually, there was only one that was significant. It was triglycerides, which was not one of the ones significant in Amsterdam. However, some consistency, again, total cholesterol and LDL cholesterol were like in a beneficial direction following mid to late gestation exposure. And nothing was significant after Bonferroni correction. Uh, Now, Colombia also stratified their lipids by sex, something that Amsterdam didn't do. Um, so we could see, whether these effects were being driven by one sex or the other. And that's very clearly what's happening. There are negative effects in females, um, and protective effects or positive effects in males. Um, and sometimes it's even on the same biomarker, like LDL cholesterol is marginally significant in females, but actually significant and beneficial in males. And after Bonferroni correction of these, total cholesterol in females remain significant. Yeah, cool. Now on to blood pressure. This one's really quick. Uh, there was no prediction of change in blood pressure, no matter how you cut the pie. Um, but if you Colombia also has a study where they stratify differently. So if they just pooled by any exposure, then they could get some like mixed results that maybe hypertension was related to famine exposure. But just for consistency's sake, I'm showing you these. So you can see how it is stratified or broken up by period of exposure. Um, then we have body composition. Both cohorts have measures of BMI and waist circumference. And here again, we see negative effects only in females, right? And actually, in the Amsterdam cohort, you see it's only an early effect, and then in the Columbia cohort, it's actually a more diffuse effect. And males have no, or male BMI and waist circumference is not predicted by any gestational famine exposure. Um, and we can actually check this even further. Lumi recently did a really, really cool study using this military induction data and found that there might even be a protective effect if you control for paternal occupation status, which is like an indicator of SES postnatally. So yeah, and this isn't a big sample. This is 371,000 people. So uh, cool. Diabetes. We only could find one study. This was actually the one study that we somehow missed with our criteria, despite it having Dutch famine in the abstract. Not sure what PubMed did to us, but we found that in Amsterdam, at least, 120 min insulin and 120 min glucose were positively associated with any exposure during gestation. Um, but the diagnostic criteria for diabetes is fasting glucose, and prevalence of impaired glucose tolerance or type 2 diabetes was not significant in this cohort, nor was it significant in their follow-up at 58. It was actually less significant. It was like zero point 0.9. So it seemed like diabetes as a clinical outcome, at least, is not really related to famine exposure according to Amsterdam. We have cancer, or we don't have cancer, but we collect the cancer results, and we could see in Amsterdam again that females maybe have an elevated cancer risk following prenatal famine exposure, but this association is a little bit suspect just because it's driven by two individuals. Because the case it's like 6 people in controls and 4 people in exposed, so kind of small. The cancer mortality is maybe a bit better. It's 21 cases, so less just like stochastic. Uh, and then in males, again, there's not really an effect. And we can see even more about males from some more military induction data that there really seems to be no effect of prenatal famine exposure on cancer risk. So up top, we just have mortality from cancer broadly. There was no effect, but the researchers actually broke it down by different kinds of cancer. And again, you see absolutely nothing. Um, So, and this is in about 40,000 people. And each one of these categories needs to have at least 100 individuals who have died from that cause. So it seems pretty clear that there's nothing here at least. Now we have cardiovascular mortality. This is like the outcome, assuming that prenatal famine exposure is going to drive some poor cardiovascular health. Presumably it would be here. And what you see is that there is maybe evidence in Amsterdam, but not really in Colombia. So it's not very consistent. You see there's the early effect. This is again driven by a really small sample size of diagnoses. It's only 6, right? And I think in the control it's 4 again. So it's impressively small. But in Colombia, it's 30 individuals in the early exposure group. Because of the larger sample size, they might be more powered. Um, so uh, here we can check the mortality as well from Amsterdam. And you see that there's maybe a slight effect in females. But again, this is driven by a really small size, or this might be driven by a really small size. I shouldn't say it is, but it could be. Um, and overall, if you include the 7 cases in men, it seems like it's no longer significantly related to early famine exposure. And we can just check this again with military induction data in men specifically. You see that maybe there's a slight elevation in late gestation, which is kind of interesting because normally the discourse is that it would be in early gestation. Oops, excuse me. There we go. Um, but if you expand that to look at, the things that go into calculating mortality from heart disease, what you see is that there's actually also maybe a protective effect against ischemic heart disease in early gestation. And again, each one of these categories needs to have at least 100 individuals who passed from that cause. Um, yeah. So just I've alluded to the military induction mortality data set a couple times. We can look across all sources of mortality in males, and it seems like maybe there's some evidence for a higher mortality risk in males from some interesting causes, like external causes. So this is transport accidents and intentional self-harm, which you see further down here. Oh, and this entire plot is ordered by direction and strength of the effect. So you can see up top, that's all in a bad direction. Um, Other natural causes is like diabetes mellitus and I think liver disease, neither of which were significant. Ill-defined and unknown causes, it's just not very clear. And then cerebrovascular disease, which could maybe be a stroke. Um, so that's something. All the way down by heart disease, here again, you have that late effect that we talked about. And then again, we have the ischemic heart disease protective effect maybe in early gestation. So uh, it's just that portion of the narrative, the cardiovascular and cardiometabolic stuff, it seems very it's difficult to summarize because there's a lot of heterogeneity. So and Chris will get into unpacking that, thankfully. I'm going to just talk about some stronger evidence for an outcome, which is schizophrenia and affective disorders. Across studies, they tend to find that uh, gestational famine exposure predicts some kind of schizophrenia or affective disorder, which share a lot of pathogenesis. They're really intercorrelated. So what you see is like with broad schizophrenia, this is from the Dutch Psychiatric Registry, that there's an elevated risk for admission to a hospital with broad schizophrenia in females specifically, and then across everyone, hospitalization with major affective disorder. And actually, there's another study that has like a weird structure, so we couldn't figure out how to plot it. But they show that actually men younger than 19 have a higher risk of being diagnosed with schizoid personality disorder using the military induction data set. So that might explain why broad schizophrenia isn't popping up, because that would be before 19, and this data set only uses post 19 diagnoses. So this seems like a very consistent effect, the most consistent, in fact. Um, and so what's kind of interesting about that is, as Chris alluded to when he quoted Zena Stein, one of the biggest findings from the original Dutch famine studies was that folate is really, really important to uh, development, right? Just to neural development. If you don't have enough folate, you're at a high risk for neural tube defects like spina bifida and encephaly. Um, and what you see is that these different schizophrenia and neural tube defects actually share a lot of share an etiology. So like being exposed to a famine seems to be a risk factor for both. There's season of birth effects, that's a risk factor for both. And then both of these two cells on the bottom are in the folate pathway. So this is methylene tetrahydrofolate reductase, right? And then so this converts, or this I think methylates folate and helps provide methyl to the rest of the body, or to cells for DNA methylation and histone methylation. And then homocysteine is part of that methylated substrate in like the SAM pathway. So very clearly a folate signal. Then just lastly, really want to emphasize like these studies have had a really big impact, and we're still discussing and using them today to help public health. So just this year, corn tortillas in California now must be fortified with folic acid because Hispanic women in California were at twice risk for pregnancies with neural tube defects. So that's a product of these original Dutch famine studies. It is really cool. All right, Chris, take it away.
Is that visible? Yeah. Okay. All right. So just to quickly recap, and I'm going to go quick. I'm not going to cover everything that I was going to cover. I have a lot of sort of interpretation. I want to make sure we have enough time for questions. We started with Barker, right? This finding that low birth weight predicts elevated risk for cardiovascular disease. We have good experimental evidence from animal models that undernutrition replicates those effects. When you supplement women's diets during pregnancy, you don't see that, whether you're looking at birth weight as an outcome or later cardiovascular disease. So when you start moving to experimental work in humans, it's not there. And then this is an attempt at a very simplified synopsis of what Sasha just went through, right? That when you look at the Dutch famine, there's some evidence for increased risk in females, mostly evidence for protection. Like you're actually better off if you were exposed to famine if you're male. Blood pressure, no effect in any of the cohorts. Diabetes, murky, but diabetes itself not being affected. The body weight effect on females is maybe one of the more consistent outcomes, I think, across the studies. But then in males, you either see null or protective effects. And then with cardiovascular mortality, you've got some negative, some positive. It's kind of ambiguous, right? And I think the point, like this is obviously a pretty difficult set of findings to wrap our heads around. And that is the point, really. Like if famine is having large effects intergenerationally on through this DOHAD pathway, it should be a simple story, right? There should be some consistency across these different designs and so forth, and there just really isn't. And so, and yet we do have relatively consistent effects of famine exposure on schizophrenia, which, as Sasha alluded to, is probably more of a micronutrient story, whereas these up here are more about macronutrients like protein, calorie, nutrition. And so, super quick, Zane and I and Julian Rutherford, we wrote this paper in Evolution of Medicine and Public Health in 2020. It's actually based on a working paper from 2012, where we argued that we should expect really good buffering, right, of prenatal nutrition in a species like us, right? So if you start with fish, there's very little buffering. Amphibians and reptiles, just a teeny bit more. In birds, you have much more buffering of early development, right? Incubating eggs, feeding chicks, etc. Then you get into marsupials, right? Where there's a direct connection to maternal metabolism through breast milk, and then placental mammals, where you layer into that the placenta. So as a result of all of that, in humans, the first 9 months you have constant temperature, stable nutrients, oxygen, protection from pathogens. Our placenta is more invasive than many mammals, and that allows the fetus to actually control maternal metabolism on some level. And so what I want to show here really quickly, right? So glucose is what's driving fetal nutrition. Of course, that's related to what the mother eats, but then she's got glycogen stores that she kicks into. She can mobilize body fat stores, which are a source of glucose, but also help they generate free fatty acids, which induce insulin resistance and spare glucose by reducing glucose uptake in other tissues. And then, of course, you've got amino acids, right? So yes, what the mother's eating is part of the story, but what drives glucose is really this entire homeostatic system. And so that is being maintained at relatively stable levels. The ability to buffer is greater in us than it is in smaller species like mice because our litters, as it were, are much smaller relative to the body size. And when we look across species, this Zane and I pulled together findings that basically compared effect sizes from the Dutch famine to comparable percentage reductions in diet during pregnancy in other species. And you can see there's a clear body size gradient showing that we are much more buffered, right? So I am just going to, the bottom line, I'm going to go to the end because I want to make sure we have time to take questions from all this. Sorry. So where this all leaves us, right? Like we started off with this idea of the first 1,000 days, that conception to the first 2 years after birth are a critical period. And if you look at groups like the Gates Foundation, right, it says we invest in nutrition to reduce preventable deaths and improve maternal and child health with a particular focus on the 1,000-day window of opportunity from the onset of pregnancy to the child's second birthday. Yes, indeed. Like conception to birth is a critical period when nutrition that received by the fetus does have long-term effects. There's no question about that. The fallacy is in thinking that we can just sort of target nutrition during pregnancy itself, like target the mother's nutrition, and that's going to get through to the fetus. I think everything that we just showed really cast doubt on that idea, right? Nutritional supplements targeting pregnancy are unlikely to have major benefits to offspring growth or health. They will help the mother, and are this still highly valuable? I think that this literature in general, this DOHAD literature, has had a tendency to focus on women as kind of vehicles for providing nutrients and that kind of thing. But actually, we need to worry about mother's health as well. And I think there's every rationale to supplement women's diets, even if it doesn't have this kind of intergenerational effect that we might hope. What I didn't get to show you was evidence that the mother's own chronic nutrition prior to pregnancy, her nutrition entering pregnancy, and her developmental nutrition are more consistent predictors of increases in birth weight across generations. And so what this suggests is that the mother's chronic nutrition does matter. What she's experiencing during pregnancy is fairly buffered, right? And so what that all means is that protein calorie supplements targeting pregnancy itself do not provide us with a magic bullet to reverse the impacts of long-term nutritional deprivation. I think what DOHAD shows us is that there's obviously a lot of development happening in utero, and there's a nutritional sensitivity to that. So when you think about health and its determinants long term, what's going on in utero is actually very important. The mother, her body and her biology has been sort of built evolutionarily to buffer that, right? And so targeting pregnancy itself is not a shortcut to improving health, which is going to require a more sustained nutritional improvement across the life cycle. And apologies that we didn't get to go through all the cool theory and so on, but I mean, we're just running out of time, and I want to make sure we have about 10 minutes now so we can take some questions.
Okay, great job, Chris, Sasha. Thank you very much. This is fascinating, really interesting. I want to give people a chance to ask some questions. Okay, Mary, would you like to ask a question? Good to see you, Mary.
Sorry, I'm on my phone. Yeah, sorry for the so yeah. Chris, this is super fascinating. And one of the reasons I find it so fascinating is that because we've been working in parallel on two papers in my lab right now. One, which might have been presented after yours at the HBA meetings, which is a meta-analysis of the effect of basically famine exposure on NCDs in adulthood.
Yeah,
And then
yeah.
another paper, which my student just defended as part of her dissertation before going back to med school, one of my MD PhD students, focusing on just famine exposure in my field site in Bangladesh. And one of the big findings we have from both of those very completely different data sets is that we see much more significant results of famine exposure in post-weaning than we do in pregnant, right? If someone was
Yeah.
exposed
Yeah, that was
perinatally,
yeah.
and right, which is of course, and of course, one of our big types of interpretation would be giving this is maternal buffering. So I think that I'm really excited to see these results.
Oh, that's great. Yeah, so that paper that came after ours, of course, I was really excited to see it because it's very much in line with what we are thinking about. This DOHAD model, for the most part, is about prenatal nutrition, right? And that's the sort of focal point of this literature. What's going on after, infancy and into childhood is not as clear. That literature has tended to focus on the effects of catch-up growth. So if you're small and then you go through catch-up growth and you experience like a lot of weight gain, it sort of amplifies the effects of being undernourished in utero and so on. So that's where most of that literature has been. And so I was
Mm.
intrigued to see your findings. I think that this Dutch famine work easily could be, you could use the same data to test that, right? By looking at infancy and
I
childhood.
think,
And
yeah,
so I think that'd be worth doing.
some of those studies are actually, probably already in Krishangi's meta-analysis, but then there are other things that could be done. That's what I was going to say is some of your data could be used to compare with early childhood. Yeah. Thanks so
Yeah, that's
much.
great.
Very
Thank you.
exciting.
Nice to see you, Mary.
Yeah. Yeah, you
Yeah, I
too.
see Bernie. I see Bernie has a hand. Hi, Bernie.
Hey, Chris, how you
Okay,
doing?
let's go to Bernie, and then after that, Nicole.
Oh, sorry if there was an
No,
order.
no,
I may
that's
have,
Nicole posted
Bernie's in the
something in the
upper left
chat
corner
that,
for some reason,
yep,
so that's who I
perfectly
figured was
fine.
next. Yeah.
Right. Thank you. Thank you very much for that. The whole maternal buffering idea seems to negate the influence of the fetus, and that it seems to presume that the mother is in control of the resource allocation in precisely the sort of situations where it would benefit the fetus the most to have control. So do you see sort of a conflict between these ideas of maternal fetal conflict and maternal buffering, and how do we account for all of the evidence about induction of insulin resistance by the fetus and so on in the context of maternal buffering?
Yeah, so I'm not aware of the evidence of fetal induction of insulin resistance as a long-term outcome. But I think this whole question of like where the genomic conflict literature comes together with DOHAD is a really fascinating one. I normally have a slide or two, at least addressing it a little bit. I sort of alluded to it by virtue of, when I talked about hemochronial placentation and the fact that the fetus has some control of maternal metabolism. That is an interesting part of the story, I think. But I think there are debates as to like how much maternal and fetal interests are really not aligned, right? Like, is it just barely misaligned or is it very misaligned? And I feel like most of the evidence, at least in humans, a monogamous species, more or less, serially monogamous, where that kind of conflict might be a little less, has, I think the evidence has shifted away from that model. That's been my sense, but I'd be interested to hear what your thoughts are on that. Yeah, so I think it's really interesting to think about how the fetus might be playing into this. But, I would think it might be more of a story in something like, let's say, mice, or a species where you've got more of that conflict than you do in us. And I would expect it to be even less in, say, gibbons, where you've got pair bonding for life or, that kind of thing. But Sasha, actually, you've thought about that. Do you have any thoughts about I'm putting you on the spot, but this is, yeah. Do you have any quick thoughts on maternal fetal conflict and where that fits into this?
I think
If you don't, that's okay.
yeah, check back in 2 weeks. This will probably be part
Okay.
of my like qualifying exam, and I am interested in conflict
Yeah.
in this context specifically, and maybe as
Yeah.
one part of my
Yeah.
dissertation. Oh boy.
I mean, David Haig is down
Thank you.
below us and we talked to him. But yeah, that's a good question, Bertie.
Okay, thanks, Bernie. And Nicole, would you like to ask your question?
Yes, thank you. And thank you for such an interesting talk. And also great efforts on, pulling all those data together. I recently did something similar and I know how much work that is. I'm also Dutch, by the way, so it was extra interesting to hear you talk about this. So I've recently gotten more interested in sex differences in birth size, so birth weight, but also birth length, head circumference, etc., in humans and other species. And unless I missed it completely in your talk, did you find any, let's say, differential effects of prenatal exposure to hunger on birth weight in males versus females? And if so, do you think that that could explain some of the sex differences in the adult health outcomes? Because I thought that was really interesting.
Sasha, do you want to talk about it? So my sense, we did not focus on birth outcomes in this particular iteration. As we write up, we're obviously going to want to dig into that. But my sense is that there was not an immediate effect on birth outcomes. There was some evidence for an effect on birth outcomes if it was late in gestation, and it was primarily probably about reduced fat deposition. I don't know if they broke it out by gender, but in general, the story is sort of like there, even if there are associations, they are despite the fact that there wasn't really much of an effect on birth weight. They did find kind of somewhat paradoxical effects in the next generation, if I recall, and this is what I'm not remembering. Like, I feel like birth weights went up in if your parent was exposed to famine in utero or something. Becomes very quirky. But Sasha, do you remember if they looked at sex differences in birth outcomes?
There's a bit about how birth weight seems to be decoupled from some of these adult phenotypes. Like a lot of these papers, they'll have their models built by prenatal exposure category, and then they'll be like, okay, there's not a lot here. We'll break it out again by birth weight, and then typically you'd see that models that were trying to predict use birth weight to predict an adult outcome in females were either more significant or had a like greater effect size.
Hmm,
Yeah.
interesting.
Well, I mean, in general, that is, I gotta say, the sex difference in these findings. I mean, to the extent that there's any consistency, there are some, at least subtle sex differences, right? Where there's a bigger effect on body weight in females, and then there's sort of negative effects on cholesterol in females and positive effect on males. There's some consistency across the cohorts in some of those. And that runs sort of counter to a lot of the other DOHAD work that I'm aware of, where the
Hmm.
prenatal exposures actually have bigger effects on males. And that's like exactly what we see in our Philippine study. Like all of the assessments of DOHAD related questions about the prenatal environment and their long-term effects, we see it in males and not in females. So I think there's a big hole, in our sort of understanding of what's going on with respect to sex differences. And yeah, I feel like it's quite murky.
All right. Thank you so much.
Yeah, thank you.
Chris, I have a quick question. I'm going to give people a chance in the chat who have questions to ask. You can raise your hand if you want to ask your question. But just a quick question while people are thinking about raising their hands. What you brought up the predictive adaptive response kind of model at the beginning of your talk.
Yeah.
I'm having trouble kind of connecting what you talked about at the end and your conclusions from this to PAR kind of hypotheses. How is this shaping your thinking on that?
Yeah, so that's the stuff I didn't have a chance to go through. So,
Oh, sorry.
no, 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 it's I had to. We just had to go fast. There was just too much. So, what I think our data show, like this analysis, and this is not new, like this is something I've written about over the last 20 years, that there's a lot of evidence that what the mother is eating during pregnancy with respect to calories and protein is not getting through to the fetus, right? So there's a buffering of short-term variability. On the other hand, the evidence that I didn't have time to show you is that her chronic nutrition, like her body weight coming into pregnancy, her early developmental nutrition, supplements provided girls during childhood, you see intergenerational effects of those longer term, more chronic experiences of nutrition. And so what I've argued is that by buffering out the short-term variability, but tracking the long-term variability, there actually could be reasonably relevant ecological information conveyed as a result of these mechanisms. And this is actually something that Sasha and I are testing with Willem Frankenhuis and Karthik Panchanathan and Nicole Valasek. So we're doing a modeling exercise where we're trying to understand under what conditions does that more stable signal, right? That ability to sort of track, buffer out the short term and track the long term, is that potentially beneficial in different kinds of environments? And so that we're kind of doing that in parallel.
Okay, fantastic. I'm not seeing any hands up. We're at the end of the hour as well. We will try to save the chat for you so you can take a look at those questions. Sasha, it might be helpful for you as you go into your prelims. It sounds like maybe there's some good questions in there for you to prepare for. But thank you guys so much for a great talk and for engaging with this really challenging question. Thank you.
Yeah. Thank you. We really appreciate this opportunity. So this was great.
Yeah,
Thanks,
thank you
everybody.
so much.
Okay. Thanks. Good to see everybody.